So now we are going to learn about CountVectorizer and Tfidf Vectorizer in case of natural language processing. CountVectorizer and Tfidf Vectorizers are both tools in natural language processing that is used to convert the textual data to numerical data. When we talk about the CountVectorizer, it creates a sparse matrix that stores the count of each word in a corpus. It is a simple but efficient way to convert textual data into the numerical data. TF-IDF vectorizer, it computes the word inverse document frequency values and TF-IDF scores all at once. It is better than count vectorizer because it also provides the importance of words which can help simplify the models. Now, let's talk into the details for the count vectorizer and TF-IDF vectorizer now. So let's see here. As I told right now, count vectorizer converts text into fixed length vectors by counting how many times each word appear. These tokens are now stored as a bag of words. So here we can see as a sample example here that we are having a basically few documents. So let's understand in detail what are these documents and what are the new terms here. Suppose here these are 3 sentences. Okay, so this is first document. We call it a document. This is a document 1. This is also a document 2. And this is also a document. So document 1, document 2, and document 3. And collectively, I will be calling as a corpus. Corpus means a bunch of documents simply. So here what we have to do, in case of count vectorizer, one has to find out that how many times a particular word appear in the sentence basically. So suppose here we have to take the entire number of words and the appearance of the word. So basically suppose I say this is good, bad, and awesome. So these are the words, these are the actually features inside NLP here. So this is good, bad, awesome. These are the 5 words inside this particular corpus. And like here, each document is having, suppose this is good, this is bad. So collectively, if I'm taking that, what are the basic features, what are the basic words here? So this is good, bad, and awesome. Okay. Now we have to check in case of count vectorizer that how many times a particular word appeared in a particular document, because I had told just this is the document 1, this is the document 2, and this one is the document 3 here. So here we are looking that suppose, let's see, in the first sentence here. In the first sentence, this is appeared, suppose this is a sentence 1, this is a sentence 2, and this is a sentence 3. So let's check it out. This has been appeared. Yes, it has been appeared in the first sentence. Is this also there? True, it is also there. So that's why we are making 1, 1. Good is also appeared. Good is also appeared inside the first sentence. If we talk about the bad and awesome, so why it is written 0? Because there is no appearance of bad and awesome words here. Okay. Now, when we talk about here, this is bad into the second document. So this is appeared. Yes. Is appeared. Yes. Bad is appeared. Yes, bad is appeared. But good and awesome is not appeared. That's why 0, 0 is mentioned here. When we talk here, this is awesome inside the third document here. So this is appeared. Yes. Is present. Awesome is present. But good and bads are not present. That's why 0 is coming here. Right? So here we can see that if the total word index has been created by this, that how many times like this appeared? 3 times. How many times is appeared? 3 times. How many times good appeared? 1 time. How many times here bad appeared? 1 and awesome appeared? 1. So in this way, the frequency is coming here. Okay. This is the count vectorizer stages here, how it count the frequency, that how many times a particular word appeared here. Now let's talk about the TF-IDF vectorizer. TF-IDF vectorizer works in a different way here. though TF-IDF vectorizer is better than the count vectorizer here. So here we can see, as the name suggests here, TF-IDF vectorizer. So here it is, it will be working just like term frequency. TF stands for the term frequency and IDF stands for inverse document frequency here. In case of term frequency, first it will be counting the number of times a particular word appear in a document. It means the number of word appeared, how many times a particular word appeared in a sentence in a simple way, and divided by total number of words present in that document. This is a TF here. Okay, this one is basically term frequency. And then there is another one IDF. That's why we call it a TF IDF. So TF IDF is equal to here. Here we need to make a log of number of documents present in a corpus here. So here we are checking it out. Number of documents present in corpus, that how many number of sentences are present is there inside the corpus, divided by the number of document where the particular word appeared. Then we have to make the multiplication of TF-IDF so that we can get entirely TF-IDF vectorizer. Basically, these are being used to convert textual data into the numerical data here. So let's check it out here in a simplified way. For an example, suppose here I'm having any two documents here, document 1 and document 2. If I want to deploy here TF-IDF vectorizer here, let's check it out that how many total number of total number of words I'm having inside the first sentence or first document. This one is the document 1 and this one is the document 2. So two sentences or two documents are there and entirely we'll be calling it a corpus in a generalized way. Okay. Now here we'll be looking that inside the first document here, how many time a particular word appear, and here how many time a particular word appeared in document 2. So here we had calculated that first of all, how many total number of words are there? Just like this is good and awesome. So this is good, bad is taken from here, awesome, and these are the words here. Now let's check it out, the TF, term frequency here, that how many time a particular word appear divided by total number of the words in the particular document. So here, if we check it out here, this is appeared one time. And the total number of words here into the document 1 here, that is 5. 1, 2, 3, 4, 5. So I will call it as this is appeared 1 by 5. So this is appeared 1 by 5. How many times is appeared? Is, if we check it out, this is, that has appeared one time out of 5. So simply one time out of 5. If I check it out here, how many times a good appeared here? It is giving you 1 by 5 here. Only one time it has been appeared out of five words here. So the frequency is given. Similarly, there is no bad, so 0 it is. And how many times awesome appeared? That one is one time out of 5 total number of words here. So it is mentioned here. Similarly as with the and. Now let's come to the document 2 here. We had covered the document 1. Now let's talk about the document 2. Inside the document 2, we are having this one time and the total number of words is 3. So hence it is 1 by 3. When I'm talking about the is here, so that is one time 1 by 3. And what about the bad time here? So that is 1 by 3 here. So it is mentioned here, is has appeared 1 by 3. There is 0 good here. Bad is appeared there 1 by 3 because it is a one time appeared out of 3 words there. And awesome 0 and is 0. This one is a term frequency because TF-IDF first calculates the term frequency. Now here it is IDF, inverse document frequency, which is clearing you here that log of total number of documents divided by the documents, the total number of documents which is covering that particular word. Okay. So here, if we check it out into the IDF, this is the IDF stage here. And this one I had told you right now, this is the term frequency stage here. So inside the IDF, one can see the total number of documents are basically 1 and 2. So total number of documents are 1 and 2. So that is 2. And the total number of documents containing that particular word. So 1 is this one and 1 is this one. So 2 are there. So 2 by 2. So here one is finding it out, the log 2 by 2. Similarly with the is, total number of documents are 1 and 2. Okay, so 2. And the total number of documents holding the is. So that is 1 and 1 is. So 2 by 2. So log 2 by 2, it is there. Similarly, one is calculating the log of good, log of bad, log of awesome, and. Once we are having the TF, IDF in our hand, then we can multiply them, term frequency into IDF. Once it is calculated here, one can find out the features here. These are the calculated values for the first sentence as for the second sentence. It means first document as well as the second document. So there are basically, when we talk about the features here, like here you can just check it out. The multiplication values coming here. So these are basically giving the importance of that particular word. So basically, term frequency, inverse document frequency gives the importance of that particular word inside the sentences here. That is the benefit. Just like rather inside the count vectorizer, it delivers only counting or the frequency of that particular word appearing into the document here. Now for this, suppose I want to implement it. Okay, I want to do some coding for that one. So I need the TF-IDF vectorizer as well as the count vectorizer. So here I just called it, you can see it here. Various libraries, I'm just calling it here for downloading the TF-IDF as well as count vectorizer. First of all, like if I want to work into the NLP, I need the NLTK. First of all, that kit I need it here. Second here, if I need sklearn.feature extraction text TF-IDF vectorizer, simply go to sklearn feature extraction page here. And you can see here, inside this sklearn.feature extraction page here, we are having a TF-IDF vectorizer as well as the count vectorizer inside this page here. There are various vectorizer here. You can see here count vectorizer. So I'm taking this, fetching this count vectorizer from this particular sklearn.feature extraction page here. Okay, so I had called them here. Okay, so I had already called them here. You can see here, sklearn.feature extraction text import TF-IDF vectorizer, sklearn.feature extraction test import count vectorizer. Okay, it is mentioned here. Now I'm also calling the NLTK toolkit. And because here I need to clean the data, I need to transform the data here. For that, I need to call the stopwords also and wordnet lemmatizer also. Okay, just to transform the entire words into its root form here. For that, I had called this NLTK, import NLTK, and I'm downloading OMW 1.4 just for the wordnet lemmatizer here. This one library is required, NLTK stop words also. I want to implement, like if I want to do NLP here, I need to do the stop words also, so that any of the words which are not required inside the entire documents, that would be removed. With the help of stop words, just like a and the full stop, any prepositions are there, they are not required. So they could be removed with the help of stop words. So that's why I'm downloading it here, stop words. And once it is there, I need to import it here into the Jupyter notebook. So here I'm just giving it from nltk.corpus import stop words here. For the wordnet lemmatizer, I'm just downloading the wordnet also. And these are just holding the warnings here. So that's why I'm just calling all the libraries here. Now let's check it out to implement any count vectorizer on certain sentences or the document here. So here we can see, suppose I'm having a corpus. Let's check it out. Suppose I'm having three sentences. Three sentences are not, these are basically documents. So I will call it a three documents. And basically these are known as an in-term corpus. Though if I talk about actual corpus are very large. They are the entire huge paragraph, story, novels, essays. They are the corpus basically. But here, as a layman language here, I'm just taking three documents here. Okay, so that we can understand step by step that how this textual data are converted into the numerical data with the help of count vectorizer here, right? So that is there. So three sentences, the cat sat in the hat, the cat with the hat. Some sentences are there. So these here, I'm just calling it as a document one here. here I'm applying here a count vectorizer. So when we are applying the count vectorizer here, I had just created the instance of the count vectorizer. I had already called the count vectorizer from here. From feature extraction text import TF-ID vectorizer as well as count vectorizer. So when I'm calling it here, you can see here, I had made the instance of the count vectorizer and I'm using here fit method as well as the count vectorizer transform method. Here I'm just passing entire document one and I just want to see into the array format. So here I'm just looking it here. What is this? It is just giving me the counting that how many times a particular word appeared in a sentence. Okay, if I'm taking the entire word array here, let's see. Here you can come here. I just put entire things into the data frame here, pandas data frame. I just holded this count array as well as count vectorizer get feature names out also I'm just taking so that I can get the entire feature name just like cat, hat, in, sat, the, with. These are the basically feature names. So I'm just extracting them here. Now here it is looking that one time cat appeared into the first sentence. There is no hat, no in, no Saturday, no sat, no the. There is a one sat and one the word inside the first sentence. When I'm talking about the second sentence, it means this particular sentence here. This is the second document here. So here we can see, we can have here cat is present there, hat is present in, sat, the is present two times here, with is not present. And into the third sentence, cat is present, hat is present, no in, no sat, two times the is present, and then with is there. So in this way, it is just making the term frequency, it is making the counting of the data. Okay. Now I'm taking another example. This one is the smallest, only 3 sentences or 3 documents I took it here. Now I'm taking here this one, a bigger number of sentences here. I can call it as a corpus because this is the larger basically. But here we can see, I'm just passing this entire sentences here, this entire list of sentences in here. Inside the data frame here. So when I'm checking it out here it is showing that there are approximately 9 to 10 sentences are there. I want to convert that into the count vectorizer because this entire textual data could be converted into the numerical data here, we can say. So how we can do that? Simply, I'm going to use a few libraries here. So I'm going to make the entire data into the lowercase first because somewhere we are getting the capital letter also. So first I need to convert into the lowercase here. After that, I'm applying here stop words. So here I apply list.apply function here. And here I'm just fetching it out the stop words. Okay, on each word basically. So here I'm taking the entire sentence using the apply method and using the lambda function where I can use one expression, one line expression. Here I'm just taking it out that take the entire sentence and split them word by word. And if word is not inside the stop words, then only that word should be coming into the join. That word should be, we are going to take it. Otherwise, if any stop word is there, do remove it. Then once we are getting the entire number of words, then we are making the lemmatization just to get the root words. For that also, I'm just using the apply method here. So that entire number of words I'm going to send it. Lemma is going to find out the root word for that particular word. And after finding it out the root word, those new root words are going to be joined as a string join function so that we can have entire one sentence there. So this is there. So the impact of this entire code is here we can see we are getting the data into the smaller format. There is no stop words also. And here entire thing is coming into the lemmatization format, means the root format it is coming. So my data is clean now here. Now here I can apply the count vectorizer, which is going to work onto the term frequencies here. So I'm applying the sentences here into the count vectorizer. Count vectorizer fit and transform method, I'm going to use it. And this count array, which is coming as a final transform, So here I'm applying into the data frame here with its feature name here. So here this is entirely, you can see the above this particular corpus which I had taken this one. So this one is a textual data and this one is numerical data which can be fed it into the computer model here. Any of the machine learning model we can feed it here. You can see here it is just given by like 0101, some of them are given here. So this one is entire numerical data here. Okay, just from forming from the I can say corpus where we are having entire textual data. Now it is coming into the numerical data where 10 rows and 43 columns are built up. And here we can send them into the models for the learning purposes of NLP here. Done. This is entirely about the CountVectorizer coding here, how we can fetch it out this coding here. Now let's go ahead with the TF-IDF vectorizer. As I told you the entire detail, the TF-IDF vectorizer is also a preprocessing technique used to convert the textual data into the numerical data here. This one is the formula which is working for the TF-IDF vectorizer here. One can see here, I'm taking some sentences here. These sentences are basically a document, 3 documents. Collectively, I can call it a corpus here. And here you can see these are the document. I want to transform this entire data into the numerical data because this is basically string data. You can call it a textual data here in a simplified way here. And now let's see here, I'm just using the same technique to make the entire data into the lowercase because here we can see few of the data are coming into the capital letter. If we're transforming into the lowercase, then stopwords I'm applying and then lemma I'm applying to make the data into the root word here. When I'm applying the entire detail here, one can see here documents are given here. These are the transform data. And these are the term frequencies here after making the calculation here that how many time a particular word appears. Suppose here it is saying go is appeared 1 time out of three there go is appeared into the 1 sentence here out of 3 sentence here. Rain is appeared into the 1 sentence out of 3 sentence. Today is appeared only one out of 3 sentence here. Okay. So entire detail here it is giving. And here also, it is just giving IDF, inverse document frequency here. So here it is finding it out log of number of sentences in the document divided by number of sentences containing into the document here. The formula is working here and it is finding it out the log of the provided word. So the words which we are getting just like go rain today, go office today, go watch football match. So their DF and IDF format is given here. For the final value, we need to multiply TF into IDF. So this one is the entire TF-IDF formula is coming here. Okay. So here TF-IDF, it is going to show you that what is the importance of the particular data. Okay. This is the benefit here. Now, if I want to apply the TF-IDF vectorizer, I need to go to sklearn.featureextraction.txt. From there, I downloaded the TF-IDF vectorizer. This is there. Fit method I'm going to use and transform method I'm going to use to do it practically. So here document which is into the string module, string format, I'm just converting that one into the this numerical data here. And here I can see after making it into the numerical format here, here it is giving me the calculated TF-IDF values here. So these were which are coming here that shows the importance of the particular word here. Okay. So basically, if I talk about TF-IDF, TF-IDF is basically much better as compared to CountVectorizer here. Okay. So here the better method is TF-IDF as compared to CountVectorizer because CountVectorizer only gives the term frequency, how many times a particular term appeared, but it never gives you that what is the importance of the word. That is not present here. So that's why TF-IDF vectorizer comes into the picture here, right? So this is overall that why do we use TF-IDF vectorizer here? Okay, so this one here, one should know the clear-cut differences between the count vectorizer and TF-IDF vectorizer, which is highly required basically whenever we are having an ample of data into this textual data, and we need to transform the data into the numerical data. Because, without transforming the data into the numerical data, we can't do any machine learning. Machine learning needs basically numerical data for the calculation of algorithms there. So that's why we need to do the entire process. Hope you had understood it. Thank you.